So here's the scenario of the question, right? Or maybe I should take a step back. So far we've been going in this direction. Okay? You know where something is, so therefore on the basis of that, tell me how fast it's going and tell me how that is changing as well. Okay? So now we want to think about going in the opposite direction, hence integration. Okay? So let's get a scenario. Johnny. Wonderful Johnny. He's been so faithful to us. Johnny is, what's he doing? He's on top of a building. Okay. So it's been a tough year for Johnny, right? So he's thinking things through. Okay. Anyway, there's Johnny. He's on the edge of the building. And let's see. How tall does that make this building? I didn't give it any height. Okay. He doesn't know how tall this building is. He just found the tallest building he could, right? And as he's looking over and contemplating, he's thinking, I don't know if you've ever seen people do this before. He takes a coin, okay, and he drops it off the edge of the building. Okay. Now, let's pause this scenario here. Whatever Johnny ends up doing, I'm just interested in the coin. Okay? Just interested in the coin. Now, here's what we know. He's on top of the building, okay, and we don't know how tall it is, so this is not a good place for us to start, right? I don't know where I am, right? But what I do know is if he just drops the coin, assuming he doesn't, actually throw it, I do know how it's accelerating, okay? Because we talked about this very briefly. The one, even if you're not a physicsy kind of person, the one force we're all familiar with is gravity, okay? So I've got gravity pulling downwards. Okay? Now, to work with gravity, a question will tell you, assume. And they'll either give you one of two options. Okay? Who knows what the gravitational constant is? The speed at which it accelerates on our planet? We give it 9.8, which of course is not exact. Right? We give that as the actual force that's being applied for gravity. But sometimes, I guess they're just being nice to us. Because this is so close to 10, sometimes they'll say 10. And you can imagine, as you change your question, as you work on your question, which one you pick kind of makes a difference, right? So always go with the one that they give you, okay? And if they don't give you one, then in reading time you stick your hand up and you say, after raging at them for not having given you the number, you say, what value do you want us to use, okay? If, and this is very unusual, but just in case you're paranoid, it's like, say, how sometimes you get external supervisors and they know nothing about maths, and for some reason they can't work the phone and call up the maths staff room, or we're in the library and we can't answer the phone because we don't have one. What you would do is, if there's nothing here, you would say, assuming gravity is, and then you just put in a value and then you work from there. Okay? Right, now, assuming this is true, this corresponds to acceleration. Okay, it's about how the speed of this coin is changing. Okay, so I'm going to say right off the bat that A is equal to, and A being a vector, direction matters. Okay, so I need to start talking about direction. Now, what would be your instinct? What kind of direction do you think I should apply to this? Downward. That's the way my arrow is going, right? Which would imply a minus sign, right? Minus 9.8. Now, I think that's a good thing to do. I recommend it. But I just want to clue you into the fact that you don't have to. You can actually make acceleration 9.8. One of the things we were saying at the beginning of motion was that this scenario, this scenario here, okay, is completely devoid of any equations. We make up the equations, okay? It's also devoid of any axis or anything like that. So we get to decide where to put it. Right? So in fact, even before this, we should be saying something else, which is let, okay? And just like in rates of change, you want to introduce some variables and some axes and that kind of thing that correspond to the question, okay? Now, as you'll see later on, there are different ways to choose where we should put things, but I'm going to say let the top of the building, or let the origin rather, be the top of the building. Okay? So x equals 0 is here. Right, maybe I'll put that in another color. Okay. let the origin be the top of the building, okay, and x be, now x, of course, is a function, it's not just a value, so that's why I'm going to say x of t, to clarify that it's a function of time. X would be the displacement. Okay. Now, some people will like to define down as positive. Okay. Now, I know that seems very counterintuitive. The reason why is so they can avoid the negative. Okay. Sometimes it'll be useful. We'll work those examples through later on. For now, I'm just going to stick with down as negative because that's what we're used to. Okay. Now, before, to get from displacement to velocity to acceleration, the process we used was differentiation. Right? Differentiate with respect to time. Okay. Therefore, in order to reverse that process, what you would expect is that we would use integration, right? We're integrating with respect to t. Right? So I would say, I'm after velocity. Okay? Velocity is going to be the integral of acceleration with respect to time. Okay? This is starting to get towards when I went to university and did maths. There were very few numbers, and you look at things and you're like, what kind of language is this? But anyway, you guys know what the integral of minus 9.8 is, right? It's just a number, so what's it going to end up at? With respect to time?
Negative 9.82.
Now, because it's indefinite, I have to deal with this constant, okay? Now, I'm going to call it constant 1. You don't have to, but generally in motion equations, in motion questions, you're going to integrate more than once. So you go further, right? So you're going to have more than one constant. I don't like having C's and D's and E's hanging around because I start to forget what they are. Whereas C1, C2, C3, or whatever, C is always constant. Okay? Where it's real. Okay, great. Now, usually in questions like this, we're not dealing with motion. We've got x's and y's, and you get some kind of information that allows you to work out what the constant is, right? So what kind of information would we need here? We need to know something about how the velocity starts or where it's up to at a certain point, right? Now, I said Johnny got to the top of the building, and he dropped the coin off, okay? So what is the starting velocity of the coin? It starts at 0. I said, he doesn't throw it, he just drops it, okay? So at that split second when he's actually released it, it's not going anywhere, and then gravity starts to act on it, okay? So therefore, I would say, okay, you could say when t is 0, v is 0. A faster way to say that is v of 0, because v is also a function of time, right? That's equal to 0. Therefore, 0 is equal to minus 9.8 times 0 plus my constant. Okay? So that's kind of pleasant. Okay, great. So now I know at any given time how fast it's going. I'd also like to know where it is, right? So to go from velocity to displacement, I'm going to integrate again. Okay, so 9.8. That t is going to go up in power, and then I have to divide by the power, right? So what am I going to get out of this? Minus
4.9.
Good. Okay, and again, another constant. Okay. Now, what this C2 is depends on how I've defined the question, right? Since I said the origin is the top of the building, and Johnny starts at the top of the building, okay? In much the same way as I did here, I can say x of 0 is also 0. He begins at the origin. Okay, he won't always, as you'll see in the next couple of examples, but this is what I've defined in this question. Okay? Therefore, 0 is equal to So now you're like, did I really have to go through all of that when it was such a simple result? What you'll find is very, very commonly, you're going to be, your initial conditions will be, you start at the origin and you're not moving. Sometimes they'll say the particle, the object, the car is initially at rest. So that gives you these kinds of very simple constants. Okay? So therefore, x is equal to... Okay, great. Now, what's Johnny interested in? Well, he watches his coin, and he wonders, because it's very small and he loses track of it very quickly, he wonders where it will be after 5 seconds, and how fast it'll be going. Okay? So, now that I've done all of this integration work, all I need to do is take t equals 5, and then substitute it. Really straightforward. Okay, so all the hard work was really here, right? I can get velocity, which looks like it's going to be minus 49. Yeah, okay. And I can get displacement, which is minus, I worked this out before. I think it's 112.5. Someone tell me if I get that right. Anyone got that? Yeah? 22. Wrong number. Okay, great. I was close. Okay, now, therefore, I'm almost finished. Because all of this is in terms of vectors, and it's not in terms of language, right? I want to conclude. Okay, so just like the question begins, let's say after 5 seconds, how do I describe this velocity? Well, it's going at 49, what are the units? Meters and seconds, right? The coin (49 meters per second). Now, I prefer saying this in positive terms and then actually say the direction in words, okay? In a downward direction. I think that's a little bit better than saying it's traveling at minus 49 meters per second. Some people will let both through, but I feel like, because we're saying everything else in words, why don't we say this in words as well? I mean, the reason why we don't write 49 is because you don't get any more information out of it. Okay. After 5 seconds, it's traveling at that speed, and it has traveled, or it is, 122 and a half below the top of the building. Now, I think that's kind of, even though it's sort of optional, to add this extra detail in about saying how long, taking a long time to say where it is, I think that's helpful because different people define x equals 0 as different places, okay? So you don't want to just say 122.5 meters from 122.5 meters, okay? You want to actually say, where's your point of reference? Because you can pick different ones, okay? Does anyone have any questions about that?
If the building is 100 meters tall.
If the building is 100 meters tall, then it would have, after 5 seconds, it will be traveling at, assuming it's not an elastic kind of coin, it's traveling at 0 meters per second, and it will have traveled 100 meters.